Hello everybody. Today I'm going to do some examples from the handout Stoichiometry Problems number 1. And this problem, you can see that I've just written out a copy of the problem itself so that I had more room to work than what was on the handout. Okay, so let's go ahead and have a look at this. I just wanted to say that this has nothing to do with limiting reactions. This is putting together our mole and Avogadro handout, our mole to mole, our mass to mass, and volume to volume style problems. And if you looked at the stoichiometry notes that had the banana in like a science lab on the front slide, it goes through and tells you to make cards, kind of like flashcards was the idea, in 4 different flashcards. And really there's 4 total tools. So if you're struggling with stoichiometry, it would be really helpful to make your own 4 flashcards. So if you want to go back to that and look at that, it'll walk you through making those flashcards. And then I'll kind of talk to you a little bit about how you would use them as I describe the problem set here. I think that's really helpful until you no longer need them. But again, if this all seems to be coming fairly easy to you, then you don't need to use those flashcards. But if you are having difficulty, making the flashcards will help a lot, because really there's only 4 total tools that you use for any of these problems. And the 4 tools, sometimes you don't use all of them. Maybe you use 1. Sometimes you use 2 together, 2 of the tools. Sometimes you use 3. I can't think of a single problem that I've given you where you would need all 4, okay? But use of all 4 is potentially possible. So let's talk a moment about what those cards were before I begin the first problem. So one of the problems, or one of the cards had, basically these are fractions. Okay, so for 1 mole, I can look up grams from the periodic table. Now, the back side of this card just had the reverse. It was just flipped. Okay? And really, that's the only 2 ways you can use this card. And this grams came from the hint, which said the periodic table. All right? The second tool that we have is that 1 mole is over Avogadro's number, 6.02 times 10 to the 23rd. Now that could be for atoms, it could be for molecules, it could be for ions, it could be for people, it could be for donuts, it could be for eggs. It doesn't make a difference. This just, in chemistry, most of the time we use them for atoms or molecules or even ions. All right, so I have to decide, though, I can't use them mixed up. So if I'm going to use this for atoms, it is not the exact same thing as answering and using it for molecules. All right, if I look at this formula right here, this has 1 molecule of N2. So if I wanted to know how many molecules were in 1 mole of N2, 1 mole has 6.02 times 10 to the 23rd. How much does 1 mole of N2 have in atoms? Well, there's 2 atoms here. There's 2 nitrogens bonded together. So there's 2 atoms of nitrogen. So I would need to take this value, 6.02 times 10 to the 23rd, and multiply by 2. Okay, so that was kind of the second tool that we had available to use. The third tool that we had is the mole ratio. Mole ratio to mole ratio. I guess I could have made this a little bit bigger. And the mole ratios come from the balanced equation. They're the coefficients in the balanced equation. So if I need to convert from one chemical to another chemical, like a product, or from one reactant to another reactant, this is the mole ratio. 1 mole of N2 is related to 3 moles of H2. So it's a 1:3 ratio. 1 mole of N2 is related to 2 moles of ammonia, the product. And 3 moles of H2, hydrogen gas, are related to 2 moles of ammonia. That's the ratio that this comes in. It's kind of like the recipe. All right? All right, so then the very last tool that we can use, and on the cards I said like mole ratio 1 to mole ratio 2. Anything can be mole ratio 1. I'm just comparing either. How do I know what mole ratio 1 is versus 2? Well, the chemical has to cross-cancel. So that's what really determines which chemical from the equation goes in the bottom and the top, because I always want to cross-cancel with the bottoms. The last tool we have is a volume, and that is 1 mole is equal to 22.4 liters. Now, that has to be a gas only, and it's a gas at STP. So it doesn't work for anything else, only gases. All right, so let's have a look at the problem itself here. So it says based on the following equation, which gives us the equation, it says if 14 grams of nitrogen react, how many grams of ammonia are produced? Okay, so what do I know? I need a number. Got to start a conversion stoichiometry problem with a number. So this is my given. This is what's known. Start with my given. What am I trying to solve for? It wants to know how many grams of ammonia in H3. So this is what I'm trying to solve for. That means at the very end, I want an answer that says grams of NH3. If I have some other units or some other chemical, then it's not going to count. It's not the solution. It's not the answer to this question. All right. So let me begin with the given. You always start with the given. In this case, we have 14 grams of nitrogen. Now, is this going to be just N? No, it's going to be N2. And you can always look to the equation. But remember, there are the 7 diatomic molecules we talked about before we left to distance learning. And the 7 diatomics went with that. Heck no halogens. Hydrogen, heck for hydrogen. No was nitrogen and oxygen. Halogens are fluorine, chlorine, bromine, and iodine. So there's a total of 7 things. So nitrogen is always going to be N2. So when it just says nitrogen, it means N2. But I can always, if I'm not sure, there has to be, what they're talking about has to be within the chemical equation. All right, so there's N2. Okay, so I have to cross cancel, and I'm going to put grams here on the bottom. And you notice that I have switched to a grid. The grid just still means the same thing as writing times and the next fraction or ratio or proportion. Okay, it just keeps it a little neater and takes up a little less space. So you'll start to see me convert. Sometimes I use one, sometimes I use the other. Doesn't make a difference. All right, so 14 grams of nitrogen, grams, and I've got grams per 1 mole. So this is for 1 mole of nitrogen. This is grams of nitrogen. So I need to look it up on the periodic table, and nitrogen has a mass of 14.01. for a single nitrogen, but we've got 2, so this is going to be 28.02, or 28. Okay, This can cross cancel. Grams, grams, and nitrogen, nitrogen. Now I have moles of nitrogen. Until this matches this, I have to keep going. There's more steps. All right, so moles of nitrogen. Okay, so once I have gone to moles, all of these have moles, which means my next step could be any of these cards. Because that's the case, many times we say when you're going to solve a stoichiometry problem, go to moles first. Because once you've got it in moles, you can go anywhere. All right, so what do I notice? Are they asking me about solving for nitrogen? No, they're asking me to solve for something else. This case, ammonia, NH3. Therefore, I need to switch chemicals. The only card that lets me switch chemicals is this one. Okay, so what is it? I need the mole ratio from one chemical to the mole ratio of another chemical. What chemical needs to be on the bottom? My nitrogen, so that I can cross cancel it. What moles needs to be at the top? Well, the new chemical that I'm trying to get to. So the old is on the bottom, the new goes on the top. So this is moles of NH3. Where do I get the numbers? I don't look them up on the periodic table. I get my numbers from the balanced equation. So there's no number in front of N2, which means that's for 1. Moles of NH3. Here is NH3. That has a 2 in front of it, so a 2 goes here. So my mole ratio, for every one of these, I make 2 moles of this. I double the amount of ammonia. Okay, so now I can cross cancel moles and moles, into, and I have moles of NH3. I check. Still not at moles. This is moles. This is grams, so still not here, which means I have another step. Okay, so if I reuse one of these cards, and typically you would never reuse this card, but I can reuse these as long as it's for a new chemical. All right, I'm not going to use them back to back. If I use this card and that tool back to back here, I've just gone in a mathematical loop. I didn't go anywhere. All right, so I'm going to use it again, use a card again, but I'm going to use it with a new chemical, and that's allowed. So here, what chemical? Well, I've got moles here, so I have to have moles here. I have NH3 on the top, so I've got to have it on the bottom. Okay, so 1 mole of, because these all say 1 mole except for this card. 1 mole, 1 mole, 1 mole. So 1 mole is how many grams? Okay, I've got a 1 mole to grams card and tool, so I'm going to go to grams of NH3. Where do I get the grams? From the periodic table. Nitrogen is 14.01. Hydrogen is 1.01, but there's 3 of them. So 1.01 times 3 gives me 3.03. 14.01, 3.03 adds up to a total of 17.04 grams, or approximately 17. Okay, my moles of NH3 cross cancel. Grams of NH3 is what I have here. I'm trying to get to grams of NH3, so now I know I'm done. And the setup is finished, and I can go back and multiply the top, divide by the bottoms. Okay, so in this case, then, if I go ahead and do the math, 14 times 2 times 17.04 divided by 28.02 divided by 1, and divided by 1 is going to give us an answer of 17.0278. It keeps going on. All right. So significant figures tells me that I can reduce that to the least amount. this is mole ratio. The given always counts. So in this case that has 2 sig figs, so I only needed 2, so I could just say 17 grams. And that would be my final answer. All right, if you're not sure about the significant figures, don't worry about it. Just go ahead and write down a couple decimal places, because usually our answers don't typically have more than 2 or 3 decimals, so you would still be safe to write out the full thing, okay? And I'm not going to focus on turning everything into significant figures. I want to focus on, let's just get the setup correct and then the right answer, okay, mathematically. All right, so that is part 1. Part B says, if 14 grams of nitrogen react, how many molecules of ammonia are produced? Okay, so what's my given? 14 grams. What am I trying to solve for? Well, I'm trying to solve for how many molecules of ammonia. Okay, before I had 14 grams of nitrogen, so I start the same way. Okay, what am I trying to solve for this time? I'm trying to solve for molecules of ammonia. Before I tried to solve for grams of ammonia. So this is molecules of NH3. So this time, molecules of NH3. Okay, so now that I've got that, I'm going to go ahead and restart my problem. So we start at the beginning. Grams here means I've got to have grams of N2. Okay, where do I get grams? Well, just like before, I get it from the periodic table. I'm using this tool. So the first step is exactly the same as it was above. And since it's the same stuff, I don't have to relook it up. I already figured out the molar mass, so I can just go ahead and write it. Okay, grams of N2, grams of N2, moles of N2, molecules NH3. Not done, I need to go on. Okay, as before, I need to switch chemicals to get to the new stuff, the NH3. So my old goes on the bottom. My new goes on the top, and this tool was the mole ratio from the balanced equation, and I did the exact same thing above. So I can see that I already figured out that this was 1 mole. This is 2 moles. And now I can cross cancel moles of N2 with moles of N2. Now I'm at moles of NH3, but I don't want moles, I want molecules. So I go on. Okay, so I look at, what did I do before? I went grams. Okay, well, I don't want an answer in grams, so I don't use that card. Do I have a card or a tool up here that has molecules in it? Yes, I do, right here. I can use this for atoms, or I could use it for molecules or ions, right? So in this case, I want to put down, it's for 1 mole and it has Avogadro's number. So moles have to be on the bottom. Why? Because I've got to cross cancel units and chemicals. So 1 mole, because it says 1 mole. That's how I know. So 1 mole is 6.02 times 10 to the 23rd. Now, my question is, do I put atoms or do I put molecules? Well, what is NH3? Is it an atom or is it a molecule? Well, it's not just 1 atom, because there's actually nitrogen plus 3 hydrogen. So there's 4 atoms here total. So this is a molecule. And it's of NH3. All right, so now I can cross cancel moles of NH3. I'm left with molecules of NH3. That's what I was trying to solve for. When I do a check, I can see it matches, and so I'm done with the setup, which means I can now go back, multiply the top numbers, divide by each of the bottom numbers. Okay, so this ends up being 14 times 2 times 6.02 times 10 to the 23rd power divided by 28.02 divided by 1 divided by 1 equals, and I hit something wrong on my calculator, so I need to put it back in. And we get this answer. All right, so 6.015, so 6.02 times 10 to the 23rd. Hey, I got Avogadro's number back out. Okay, and that would be correct. Right. How do I know that that's the correct final answer? And can I do a quick check? Yeah. Most of the time in chem, we're focusing really on cross-canceling units and chemicals, but we can also cross-cancel some numbers here. I could say that this is 1 and 28 is double, so that's 2. So now I have a 2 and a 2, so this can cross-cancel. And the only thing I have left other than ones is Avogadro's number, 6.02 times 10 to the 23rd, which is my final answer. Okay? All right, so let's go on to part C. Part C says if 6.02 molecules of nitrogen react, this is my given, how many molecules of hydrogen gas will react? That's what I'm trying to solve for. Okay, so I'm trying to solve for molecules, and I'm going to start to abbreviate molecules, M-O-L-E-C, because moles is abbreviated M-O-L. All right, so this is going to get abbreviated M-O-L-E-C. So molecules of what? Hydrogen gas. How much is hydrogen gas? Just H? No, it's one of our 7 diatomics, so it's H2. How do I know? Look back up at the original equation. See, it's got H2. All right? I don't care that this has H3 in it. I need just hydrogen all by itself. And this has nitrogen with it. This makes it something else. It's not called hydrogen. This is still called hydrogen, even though there's 2 atoms. All right, so that's what I'm going to solve for, H2. Okay, so I'm going to start with my given, 6.02 times 10 to the 23rd molex of what? Nitrogen, N2. Okay, so I have to use a tool that has molex of N2 in it. Okay, so what has molecules of N2? Well, back up to my tools, the top. The only one that has molecules is this one. Okay, so it's got Avogadro's number. It goes with the word atoms or it goes with the word molecules. So let me go back down. Here's the word molecule, so the number is 6.02 times 10 to the 23rd, and that's for 1 mole of N2. Okay, so my molex of N2 can cross-cancel, my molecules cross-cancel. Now I have moles of N2. This is not the same thing. It's not even the same chemical. So once again, so what makes it a stoichiometry problem, I change chemicals. So go to moles, and then you can change chemicals. Okay, so now that I have moles of N2, I'm going to use the mole ratios from the balanced equation. What was the mole ratio? Well, for every 1 mole of N2, and that's on the bottom. Why? Because I need to cross-cancel not only the moles, but the chemical M2. before we went to NH3. This time we're not going to NH3. So I need to know how many moles of hydrogen are in the equation. So go back to the equation, the top. For every 1 and 2, there's 3 hydrogens. Hydrogen gas molecules. Okay, so for every 1 mole of N2, for 1 mole of nitrogen, there's 3 moles of H2. All right, now I have the right chemical, but this is moles, this is molecules, so I'm still not done. I need one more tool, but I already know this is here, so it has to automatically be on the bottom so I can cross cancel. So I've got 3 moles of hydrogen. For every 1 mole of hydrogen, how many molecules are there? Well, again, if I go back to my top 1, 2, 3, 4 tools, the only tool that has the word molecules in it is this one. So it's got Avogadro's number with the word molecules, and that's for 1 mole. So if I go back down to problem C, 1 mole of H2 has Avogadro's number, 6.02 times 10 to the 23rd molecules of H2. Okay, cross cancel my moles of H2, and I look to see this has molecules of H2, and I'm trying to solve for molecules of H2. And I lucked out because I'm at the end of my space, and I didn't really have room right here for another step without erasing this. So I have now the ability, I've got the setup correct, and now I can go back and I can multiply my top numbers and divide by the bottom. But can I also do some cross-canceling of numbers? Yeah, I can cross-cancel 6.02 times 10 to the 23rd, what I began with, and this one. What does that leave me? Well, it leaves me with, okay, this becomes a 1 and a 1. There's 3 and 6.02 times 10 to the 23rd divided by 1 and divided by 1. So that's all I need to do is 3 times 6.02 times 10 to the 23rd. And I end up with an answer that is 1.806 times 10 to the 24th. Okay, and that is my final answer for part C. Okay, so let's do the last part of this problem. It says, part D says, if 1.5 moles of nitrogen react, how many moles of ammonia are produced? Okay, so what's my given? I got to have a number. This is my given. 1.5 moles of N2. There's my given. Reacts with how many moles of ammonia are produced? This is moles of ammonia. That's what I'm trying to solve for. That's what my answer is equal to. And ammonia's formula is NH3. Okay, so there is my end answer. Okay, so if I then start, normally in all the other problems we were going to moles, go to moles, go to moles, then change chemicals. Well, I'm already in moles, so I don't need to go to moles. So if I have moles, I can do any of the 4 cards. Okay, so if I can do any of the 4 cards, I can change chemicals right off the bat. And that's what I want to do. I want to switch my chemicals. Why? Because I can see this is N2, nitrogen gas. This is NH3, ammonia gas. Okay, so 1 mole of N2. Why 1 mole? Because we can see that the mole ratio from the balanced equation, clear at the top, 1 mole of N2 makes how much ammonia? 2 moles ammonia, NH3. Okay. So in this case, my new old chemicals on the bottom, new chemical, 2 moles, NH3 goes here. I can cross cancel. I'm left with moles of NH3. What am I trying to solve for? Moles of NH3. Yay! I'm done with the setup. There is no more. So this is quite short because this was a mole to mole problem. The only thing I needed was the mole ratio from the balanced equation. So 1.5 times 2. I don't even need a calculator for that piece. It is 3. So 3 moles of NH3 is the final answer. Hope this helps. And regardless of the problem, you can always use the 4 tools to solve any stoichiometry problem. Have a great day.